Hi, and welcome to our sixth and final lesson in this unit. A proof is a logical argument presented with factual statements in order to arrive at a conclusion. Constructing a formal two-column proof is like solving a puzzle, where everything needs to fit in an appropriate place. So throughout this unit, we've used some informal proofs, and now we're going to put them into this structure, where we have our statement or our hypothesis on the left side, that's the if part of our statement, and the reason on our right side, which is our conclusion or our then part of our statement. Let's start writing proofs by revisiting the steps involved when solving an equation. In order to add, subtract, we apply the addition property of equality, APE. When we're multiplying and dividing, we apply the multiplication property of equality, MPE. Recall the dividing is the same as multiplying by their circles. So let's start with an equation here. Given 4x subtract 12 equals to 10, prove that x equals to 5.5. So if we were to work out this problem, go through the steps, we would end up with these as our three steps here. Okay? So we start with our equation that's known. That would be our given. Always list all given information as you're working through a problem. It doesn't necessarily have to be in the exact order as long as you list it there. In order to get to our next step, we would have to add 12 to both sides. So that's our addition property of equality. And then to get to our final step, we would be dividing by 4 or multiplying by 1/4. So that's our multiplication property of equality. So you see that this proof is completed because we are able to get to our outcome x equals 5.5, and we can justify each step along the way. Why don't you pause here and go through the three steps related to writing this two-column proof. Okay, so we're back here. We started with our equation, 3 quantity x plus 7 equals 12, which is a given piece of information. After that, our first step would be to divide by 3 or multiply by 1/3. So that's our multiplication property of equality. And then the last step here would be to subtract 7 or in order to get, and that's our addition property of equality. So we see that this proof kind of simplifies the idea that as long as we have all our evidence on one side and our reasons on the other, we've had completed our proof. Now we're ready for some triangles. Prove whether or not triangle LKM is congruent to triangle TUS. So again, let's start with our given information. When you're given a diagram that has matching markings, that tells you that those two parts are corresponding. And that they're the same. Corresponding means matching. So we can start with angle N is congruent to angle S. That was given. Angle K is congruent to angle U, which is also given. And side lengths ST correspond with KL, which is given. Now looking at this diagram, you might be thinking, okay, I have an angle and an angle on the side, an angle and an angle on the side. So can we prove whether these are congruent or not? Let's go to our next step. In this case, ST here actually corresponds with side length ML. And how do we know that? Well, we see here the markings, the two angle markings here, and then no angle markings there, two angle markings here, angle markings there. So even though these are corresponding sides, they're not congruent to each other. So in this example, triangle LKM is not congruent to triangle TUS because they can't use the angle side postulate. So this leads us to one very important thing. Don't make assumptions. So when you're working through these proofs, you must show all of your evidence to lead to either a valid or an invalid outcome. You never know if the teacher is going to ask you to prove something that's not possible. Let's try again. So here we have our diagram in which we have a four-sided figure. It's broken up into two separate triangles. So given that ADC is congruent to BC, AD is congruent to BC, excuse me, and BC is parallel to AD, these sides here, we want to prove that triangle ABD is congruent to triangle CDB. I'll start with what you know, right? Your given information. Some given information is up here, and some given information might even be in our diagram. So we have side length AD is congruent to side length BC. So that would be given. Side length BC is parallel to AD, which is also given. DB is a transversal, right? And it's given, even though it's not listed in this information here, because these two sides are parallel to each other. You see that this line, if we were to extend here and extend here, extend there, we have a transversal segment for DB. So remember that also gives us some other relationships that we can explore about the angles. So in this case, angle 1 is congruent to angle 4. And as I just said a moment ago, if you extended this side length here, and extended this side length, and extended your transversal line in the diagram, you would see that these two here are actually the alternate interior angles. We also know that DB is congruent to itself. Recall that is the reflexive property. So here in my one triangle, I have a side angle side, and the other triangle I have a side angle and another side. It's a shared side in both diagrams. So triangle ABD is congruent to triangle CBB. Now many of you may have been thinking, well, why can't I use angles 2 and 3 as part of my proof here? And the reason that those don't work is because those angles are not the alternate interior angles in the diagram. So if I were again to sketch this out and draw your parallel lines here, right, here and here, extend out your transversal, you would see that angles 2 and 3 are not alternate interior. So you cannot make the assumption that just because they're inside the two figures, that those would actually be the corresponding angles. Now that we're getting it, let's try one last one. So sketch this diagram, write down the given information, and try to complete the proof here for RS is congruent to TS. To give you a little hint, there are 6 steps involved in this one. Okay, now that you're back, let's start with our given information. How many pieces of given information did you have? First would be RV is congruent to TV, and that's given. And VS bisects RVT. So I have this side here bisecting that. That's going to tell us that angle 1 and angle 2 have a certain relationship, right? Bisecting meaning that it cuts it in half. So that becomes another piece of given information. And we would justify that with the definition of bisect. Since it cuts it in 2 equal parts, we can write the idea of definition of bisect, or VS bisects angle RVT. VS is congruent to itself. If you recall, that would be our reflexive property. So now if you're marking up your diagram, you might have a mark over here, you might have an angle mark there, you might have another mark here showing that, and then something here, here, and here. And that would tell you that triangle RSV is congruent to triangle TSV by the side angle side postulate. But the question was asking us to prove if RS is congruent to TS, right? So I have RS here and TS here. Recall from our lesson with Rodin's thinker, one of those theorems that helps us. Once we know that two triangles are congruent to each other, that told us that everything in those triangles is also congruent. So RS is congruent to TS, and if you recall, that is CPCTC. Corresponding parts of congruent triangles are congruent. And we can only use CPCTC after we have proven the two triangles are congruent. So this is a special kind of part of a proof. You can't have this anywhere earlier. It's something that only comes up at the end of the